All right, here it says, according to the Oregon Bar Association, approximately 65% of people who take the bar exam pass. Okay, so 65% of examinees pass. And here we're going to look at 200 randomly selected people, randomly selected exam takers. And it says, find the probability that at least 67% will pass. All right. So let's check our conditions here, okay? Because what we want to do is we want to use the normal model. So conditions. All right. So we want to check, were the people randomly selected? Are they independent random? Yes. Okay. Is our sample large? Large sample. All right. So we do 200 times our p, which is 0.65, n times p, and that gives me 130. So that's bigger than 10. That's good. And I do 200 times 1 minus 0.65, which is 0.35. That gives me 70. Also bigger than 10. So our sample is large. Okay, and is large population, is 200 more than 10% of all exam takers? No, it's not more than 10% of all exam takers, so that one checks out. So we've got a normal model. And what is the mean of this normal model? So p hat follows a normal model, I should say. All right, and the mean is going to be the same as the population proportion p. So the mean is p, which is 0.65. And our standard deviation of this normal model is our standard error, which is equal to the square root of p times 1 minus p over n. So I've got the square root of 0.65 times 1 minus 0.65, which is 0.35, divided by n, which is 200. I have to crunch this out. 0.65 times 0.35 divided by 200, square root, and I get a standard error, which is 0.0337. Okay, and now I'm going to draw a picture. In the center, I put the mean. The mean is 0.65. And what I'm curious is what proportion, find the probability that at least 67% will pass. So I'm going to draw a cutoff line at 0.67. And I want to know what is the probability of being 67% or more. So I've got to find my z-score. 0.67 minus 0.65 divided by 0.0337. Alright, so when I punch it in the calculator, what I'm typing in is 0.67 minus 0.65 divided by answer, okay? Because I left this number in there. When I crunch that out, I get my z-score to be 0.59. I get a z-score of 0.59, and I'm going to look this up in the z-table. When I look up 0.59 in the z-table, it's going to give me the area to the left. So 0.59, the area to the left there is 0.7224. Alright, so the area over here is going to be 1 minus that. I have to subtract that from 1. So 1 minus 0.7224. Alright, That's going to be 0.2776. So that's this area over here. So what's the probability that at least 67% will pass? 27.76%. Based on our normal model and t-table that we were using here. Great.